Welcome back to Edexcel Science channel. And now we are at question 13 from June 2026, Edexcel IAL Physics Unit 1. So question number 13 is saying, in a game of tennis, a ball collides with a tennis racket. During the collision, there is a change in velocity of the ball and the racket. However, the mass of the ball is less than the mass of the racket. Explain how the magnitude of the velocity magnitude of the change in velocity of the ball compares with the magnitude of the change in velocity of the racket. Now, this keyword, right, collision, tells me that this question is about momentum, right? That two objects, the ball and this is the racket. I know it's really bad. I know. So this ball and this racket are colliding with each other. So I am going to answer it using momentum. This is a sample answer, but let me explain how we got here. So according to the conservation law of momentum, we know that before a collision happens and after a collision happens, right, the momentum is conserved, meaning that the momentum before and after the collision is the same. So let's assume that momentum of the ball and momentum of the racket, right? Both changes in momentum are the same before and after collision. However, the question is asking what will happen to the magnitude of the change in velocity of the ball compared with the racket. We know that momentum is equals mass times the velocity. Now, the change in velocity for the racket will be far less than the change in velocity of the ball. The reason being, since the mass of the racket is larger, it requires a smaller amount of velocity to attain a certain level of momentum. However, for the ball, since the mass of the ball is very less, it needs a very high amount of velocity to attain the same momentum as the racket. In a sense, the ball, right, the momentum of the ball and the momentum of the racket, they're trying to keep up with one another. The momentum of the racket, right, for mv, the the velocity can be less since the mass is very high. But for the ball, the velocity needs to be very high to be equal to the momentum of the racket. Therefore, the change in velocity of the racket is less than the change in velocity of the ball, or you can say it the other way, that is, the change in velocity of the ball is way higher or is greater than the change in velocity of the racket. I hope that is clear. Question number B. A tennis ball should have a mass between 56 grams and 59.4 grams. The initial speed of the ball is 22 meters per second towards the racket. Immediately after the collision, the speed of the ball is 14 meters per second. Okay, away from the rocket. Okay, so the direction has changed. When the ball hits the racket, the time taken for the collision is 0.034 seconds. The mean force on the racket is 61 newtons. All right. Now, there is a lot of information here, so I would like to list them down because that helps me to have a more clear thought process. So I have a initial velocity u of 22 meter per second, and I have a final velocity of 14 meter per second. The total time of collision is 0.034 seconds, and the average force is 61 newtons. Now, my initial thought was that I would like to do this question using the conservation law of momentum because that is the usual trend. However, I cannot use m1 u1 added with m2 u2 equals dot dot dot. I cannot use this one. The reason being, I do not know a lot of the information in this equation. I do not know the mass of the racket. I do not know the velocity of the racket. I do not know the final velocity of the racket. So um, this cannot be used. So I have to use a different approach. I have to find out the mass of the ball somehow. So since they have given me the force, I can use force, the classic force formula, F time equals mass times acceleration. However, the acceleration is unknown. But then again, I know the V, U, and T, so I can use this formula. Acceleration is equals change of velocity per unit time. So this is my thought process, basically. And I'm going to do it in the reverse order, right? So let's do it. So let me find out the acceleration first. So it should be, okay. So the initial velocity is 22 and the final velocity is in the other way. So I'm going to give this one as negative. The reason being, imagine that, okay, let me remove this information. This is not needed in number B. Okay, so imagine that the ball, right? Let me move it down. Okay, so let's imagine that the ball is going towards the racket at a velocity of 22, right? However, when you have hit the ball, right? When you have hit the ball after the collision, now the ball, let me use a different color. Now the ball is going in the other direction. So for this direction, I'm going to use a negative sign in front of it, indicating a change in direction. So I can use um, minus 14 minus 22 divided by the time of the total time of the collision. So it should be negative 1060 meter per second. However, if you check the marking scheme, they have taken this one as negative. Both are fine. If you take this one, basically you have to take one of them as negative to indicate a change in direction. If you take this one as negative, then this will be addition and there won't be any negative sign. That's the difference. Um, Now we can use F equals force time, sorry, F equals mass times acceleration. So the mass is force over acceleration, 611060. So it should be about 0.0575 kilograms. However, I am going to convert it to grams. So it should be 57.5 grams. So they said that it needs to be between 56 and 59.4. So you have to write a statement which carries 1 mark that yes, the mass is between 56 and 59.4. You have to write it, otherwise you won't get that mark. That is all for this video. See you in the next one.